There are several properties of exponents. Some of these properties can be easily explained. For instance, suppose you multiply the two powers of a to the mth and a to the nth. So a to the m means you have m factors of a, and you're multiplying by n factors of a. When you combine it into one big multiplication problem, you have m plus n factors. So you can see that a to the m times a to the n is a to the m plus n. So and that is the product of powers property. So you let a be a natural number and let m and n be whole numbers. That is, a is a number that's greater than 0, whereas m and n could be 0. To multiply two powers having the same base, you keep the base, leave it the base alone, and add the exponents. So 2 squared times 2 to the third is 2 to the fifth, 2 to the 2 plus 3. A to the mth times a to the nth is a to the m plus n. Another property is the quotient property, quotient of powers property. And basically, when we use multiplication, we add exponents. When we use division, we subtract. So let a be a natural number and m and n be whole numbers, and let's assume that m is greater than or equal to n. That's not absolutely necessary, but we'll go ahead and use it for the time being. To divide two powers having the same base, you keep the base and subtract the exponents. So 3 to the 7th divided by 3 squared is 3 to the 7 minus 2, or 3 to the 5th. A to the mth divided by a to the nth is a to the m minus n. So, for example, let's write each of these as a single power, then identify the properties used. So g to the 5th times g to the 4th times g to the 3rd, I would use the product of powers property. This can be written as g to the 5 plus 4 plus 3. So g to the 12th. For part B, there is a product of powers property on the top, so y to the 19th plus 12. But we're dividing by y to the 21st, so I would subtract that 21. And that comes out to be y to the 10th. Another property to talk about is the power of product property. And that is, if you're raising an exponent to some product, then the power of each factor is also being raised to that exponent. So 2 times 5 to the third is 2 to the third times 5 to the third. So it's sort of like a distribution property, and that exponent kind of distributes through. But it's not quite distribution property. Anyway, a times b to the nth is a to the nth times b to the nth. So 5a to the third, 5 times a to the third, that's the same thing as 5 to the third times a to the third, which you can also write that as 125a to the third. And that's about as good as we're going to get. 7 times c squared is 7 squared times c squared, or 49c squared. 6ab to the 7th is 6 to the 7th, a to the 7th, b to the 7th. And 6 to the 7th, I'll just leave it as that. One final property to talk about is the power of a power property. And that is, you're raising, you have some exponential expression here, and you're raising it to another exponent. So to find the power of a power, you multiply the two exponents. So 4 to the third, that squared is 4 to the 3 times 2 is 4 to the 6. And you can see that 4 to the third squared is really the same thing as 4 to the third times 4 to the third. So if you add exponents, you get 4 to the 6. So this is just really a case of repeated addition. In general, a to the m times to the nth power of nth is a to the m times n. So 2 to the 4th squared, that'd be 2 to the 4 times 2, which is 2 to the 8th. Make sure you don't confuse it with something like 2 to the 4th times 2 squared, because that one you would add exponents, which is 2 to the 6th. That's different, and usually I find students confusing those two properties, but 2 to the 4th squared only has that one base, whereas 2 to the 4th times 2 squared the base appears twice. For part B, 5 to the third times 0, that's really 5 to the 0, or you can just say 1.